All right, so we're on part 3 of modeling and application with exponents. So we're going to look at a couple problems and apply what we know about exponential functions to that. So here we have our friend Rohiza. Rohiza has an above ground pool that holds 20,000 gallons of water. She notices that the pool seems to be losing water continuously through a leak at a rate of 1% of the total volume of water every hour. Write an exponential function of the form f of x equals a times b to the x to model the scenario. So we did similar problems like this in the beginning of the year. I know beginning, like going back to first 6 weeks, but you are still going to do the same thing, and you guys are perfectly capable of figuring it out. So I believe in you. But we're going to start off with what we kind of talked about in the beginning of the year. We're going to mark our text. So we have 20,000 gallons. That's our initial. She knows the pool seems to be losing water continuously through a leak at 1%. That's our decay rate, right? Because we're leaking. So we have a decay rate instead of a growth rate. Okay. The volume of water every hour, right? An exponential function of the form. So when we remember from the beginning of the year, we would start off by making a table, right? So we start off with that table of data. And if it's our initial, that means that that's our 0, our 20,000. Our initial also meant that that's our A value, right? And then next we fill in the table with an additional value. So let's say we use 1. So after 1 hour, I've leaked 1% of my water. So I need to leak 1%, which means that I'm keeping how much? If I leaked 1%, then that means I'm keeping 99% of my water, right? So that would be that my 20,000 times 0.99 is what I'm keeping, right? So that's our table as analyzing what we have. What I'm keeping, that is my change. This is my change factor, right? And your change factor, that is your B. So you have everything you need to write your model. So our model would be f of x equals our initial, which is 20,000, times our change factor, which is, or I think I wrote that backwards. Nope, change factor. I think I'm doing it. I wanted it to be that way. Words are sounding words. So this would be our model. Okay. And then now from here, once I have this model, I can figure out, okay, how much water is going to be left after 2 hours? How much water is going to be left after 3 hours? Whatever it may be. Okay. Now, if I wanted to do how much water I'm losing every hour, then that would be writing it as the 0.01. But now I have the model and I can go from there. Okay. All right, let's get our next example here. So it says example 6. In 2017, the average value of a vintage Bronco SUV in perfect condition was $47,025 compared to $23,400 5 years earlier. Write an exponential function to model the scenario, assuming the percent increase in value of the vintage Bronco occurs continuously. Then use your model to estimate the value of the vintage Bronco in perfect condition in 2021. Explaining your reasoning. This time we're going to use this model. We're going to create a table and we're going to use Desmos to remind ourselves how to solve this there. Okay. So in 2017, the average value of the model was, so we were here and we were at 2017. In 2017, we were at 47,025, right? And then 5 years earlier, which would put us at 2012, right? We were at 23,400. Okay. And it says write an exponential function to model the scenario, assuming the percent increase in value of the vintage Bronco occurs continuously. Then use your model to estimate the value of vintage Bronco would be in 2021. So we're looking for what would be the cost of our Bronco in 2021. Okay. Because it's occurring continuously, we know that we are looking for an exponential model, right? And it also says find an exponential function. So we're going to use our Desmos to figure out what is our change. And then create our equation from there, right? So looking here, 2017 and 2012, I'm going to show you what happens when we put those in the calculator. And then we're going to talk about what are better options and numbers we could use. So I'm going to open Desmos, clear this out, and I'm going to add a table. So in this table, I'm going to start off with putting in 2012 and putting in 23,400. And then I'm going to put in 2017. And I'm going to put in 47,025, right? So those are the values that are going in. And now I'm going to hit this little guy. Now, remember, 2 points can either be exponential or quadratic, but we already told us that we're doing exponential. So we're going to click on a regression model, and we're going to go to exponential. Notice how large our values are right here, okay? Because these are some extremely large values. Instead of us using 2012 and 2017, we could use 0 and 5. Does that make sense? So we're going to change our 2012 to our beginning value. We're going to change our 2017 to 5 years later value. And now we're going to readjust. Now we get a more manageable equation that we can work with, okay? So it ends up being a little more manageable equation that we can use as our estimation, all right? Now, because we let 2012 be our 0 and we're looking for 2021, we need to know how many years later is that, right? So we're essentially doing 2021 minus 2012. And so we're looking for what would be the price of my vehicle 9 years later. Remember, on here, you can click on the tool, open up your table, and you can type in whatever value you need. Well, we need the value 9 years later. So we're going to type in 9. When I type in 9, it tells me that the value of my vehicle would be $82,189.55. Okay? So let's kind of recap what we did here in our notes. All right. I'm trying to adjust my window so I can write again. All right. So we created our table, right? So we read our text, created our table. From the text, we had our values. So we had our 2017, and we had 5 years later, meant 5 years earlier, which meant 2012. And it told us continuous, and it created an exponential model, which we did. In Desmos, we then created our table. But in our table, instead of using 2017 and 2012, we used the values of, this was our 0, this was our 5, and therefore this had to be our 9. Okay? And then from there, we were able to figure out what equation would best model, because using the years was too large of a equation to start off with. So when we finished, we ended up with our model being f of x equals 23,400 times 1, and we're going to round to 15 to the x, because the 8 would round the 9 to a 10 with the rollover. So now when we looked for f of 9, how many in 2021, we ended up with 82,100. That's a weird 89. 189 and 55 cents. Okay, so writing it as a sentence, the Bronco would be valued at $82,189.55. Okay, so again, this should kind of feel like a little bit of a review, putting things together, and hopefully you're like, I got this. All right, awesome.